For loops allow us to repeat our code for a certain number of times. In the sandbox, when we run this, we're going to see Tracy draw a circle, and then she's moving forward for a certain number of pixels. And we're going to dig into how this works. Our first question is, what did for I in range 30 do? So it was repeating the code circle 20, forward I, print, and it repeated that 30 times. Specifically time 0 through 29. Notice on our first run through, this is 0 because the first run is considered the 0th attempt at doing it. And it will go all the way up to the 29th try, which if you include 0 is the 30th try. So a for loop will repeat code, specifically the code that's indented. If something was not indented, this would not be part of the repeat. It needs to be 4 spaces in indents. It will repeat that code that many times. And I just have a print statement here using I, which is this letter, which is keeping track of the count of what try number we are currently on. So looking at the printed message, how does the distance between circles change? Well, we'll notice that every time we move forward, we're not just moving forward the same amount, but we're moving forward whatever try we're currently on. So at the beginning, we were really scrunched together, and then over time, every time it was stretched out by 1 more pixel. So the first try, it went forward by 0, then it went forward by 1, then it went forward by 2, then it went all the way forward to 29 pixels. So what number does I start at? It starts at 0, and it goes all the way up to whatever number that you include, but it doesn't run that number. It's the stopping point. So it goes 0, 1, 2, 3, 4, 5, 28, 29, and when it sees 30, it shuts off. It stops. So it happens 30 times, including 0, but not the 30th try. For the last printed message in Sandbox 1, why is the final movement 29 pixels and not 30? Same idea. It's because the 0th try is included, so the distance between those last 2 circles is not 30 pixels, but it is 29 pixels. For the for loop breakdown at the bottom of both programs, what does for tell Python to do? So we could take a look that for is telling Python that we are repeating something. So we are repeating the indented code, and then I is simply a counter that changes each time. Theoretically, I could say for David in range, as long as I include the word David, which is a random thing that will keep track of it, it would work it just as well. Now the command David is what's keeping track of it. Maybe put your own name, could be kind of cool. So I is just a variable, like in math class. Range creates a list of the numbers we're working with, which starts at 0 and goes up to the number right before the number we get to. So that list includes 0, 1, 2, 3, 4. There's a total of 30 numbers in that list. So it will repeat for 30 times from 0 to 29. And then every time it goes through the loop, I becomes the next number. As it finishes the loop and it circles back to the beginning, it goes circle, forward, print, repeat, circle, forward, print. And on every time it gets to the end, I increases, it increments, by 1, which allows us to then use it as a way to repeat for a certain number of times. So in your own words, try to explain what I does in the program. Just for fun, we asked ChatGPT, the I in for I in range 5 is like a counter, tick, tick, tick. It starts at 0 and goes up by 1 each time the loop runs, stopping before it reaches the number we put. In the case of this example, it was 5. And now the second sandbox looks like this. And the goal of the second sandbox is to show you that I doesn't have to go up by 1. You can actually control that number, that parameter. So in this example, every time we repeated, it incremented by 1. Now, we didn't use, you'll see for I in range 30, we only put 1 parameter in that number, just the 30, which is going to be the stop value. But we actually have 3 values that we could put into a loop. Those 3 values are the start value. So normally we start at 0 if we don't include it. and we have the stop value, and you could also include the step value. So let me show you how this works. Normally our start value is 0, and I run that, and you'll see that it goes 0, 10, 20, 30, 40, 50, 60, 70, and 90. But I could change that start value from 0 to 5, and functionally we draw the same thing, but you'll see that the value working behind the scenes goes from 5 to 95. You'll start to see a difference when I make that start value 10, where we're actually going to have one less circle, where there's only 9 of these as opposed to 10 of these. The 0th try didn't run, and it increased up to 90. So I have full control of the start value. The stop value, if I wanted to go all the way up to 1,000, it would draw a lot more circles, and Tracy would keep going until she hit the value of 999, because when it adds 10 to that, it gets to 1,000, and 1,000 is the stop value. It's not included. So this currently will run 10 times, and if I wanted to maybe increase the step value over to 20, we can see that it only draw 5 of those, starting at 0, 20, 40, 60, 80, and then when it tries to do 100, it can't, it's at that value and it stops. So we can control the start value, the stop value, and the step value for loops. As for why we would ever use this, well, imagine that you're playing a video game and you're making one where, like a Mario game, you're trying to place some coins every 10 steps. You could use a loop with these step values, so the loop places coins every 10 units without you needing to manually list them. Sometimes things need increments. One final, more realistic example. If you wanted to make a countdown, like 3, 2, 1, go, you could do that with just simple print statements. But you could also use a decreasing increment where the start value is 3, the stop value is 0, and our step is going down by 1. So in this case, it's 3, 2, 1, go, which is great because maybe your timer is 1,000 and you're counting down and the seconds in your video game are going and you really want to have the game count down. This would be a great way to do that countdown before it eventually gets to the statements. So it could be really useful in counting down or even counting up if you're counting up to something. That's it. Hope you guys enjoyed. See you guys in the next video. Peace.